In this example, we need to sketch the parent function for the absolute value function. This is going to look like a v, kind of my favorite function. So this is f of x is equal to the absolute value of x. Notice there's no other number out here. There's no other number inside or over here. The parent function means the simplest form of that function. Also, we're sketching, so we need to do this by hand. Let's choose inputs of -2, -1, 0, 1, and just for grins, let's pick something a little bit higher, maybe 5. The inputs can be really whatever you want, but you do have to look at the function and see which values might work. So for this one, any negative or positive value would work. You can take the absolute value of that. Also, it looks like we end here at -7 and +7 on this graph, so we wouldn't want to pick values of x that are outside of the values that are on the x-axis in this case. If these aren't labeled, then you can make the tick marks whatever you want, and you have some more choices there, but we do have these labeled, so we want to make sure to keep that in mind. F at -2 is going to be the absolute value of -2, and remember, you can think about absolute value in a couple different ways. One way to think about it is the distance from 0. So -2 has a distance from 0 of 2 units. Remember, distance is always positive. Another way to think about this is when you have absolute value and you just have a number on the inside or a quantity, what you'll do is you'll just take the positive value of what's in there. So we've got 2 here. F at -1 then would be the positive value of -1 or 1, or the distance from -1 to 0, which is still 1. F at 0 would be the absolute value of 0, and the distance from 0 to 0 is, well, 0. F at 1 would be the absolute value of 1, which is +1. Remember, just take the positive value of what's inside the absolute value bars. F at 5 then would be the absolute value of 5, which is 5. We'll plot these. -2, 2, -1, 1, 0, 0, 1, 1, and 5, 5. So 5, 1, 2, 3, 4, 5 is right here. And you can see the shape that this thing makes. So I'm going to use my ruler for this one. With the previous graphs, we didn't want to use a ruler because they were, well, curved. And you'll notice that the absolute value function consists of 2 lines, or at least 2 rays if you want to go with some geometry terminology, because they all have a common endpoint here. That point's called the vertex. And it just splits the diagonals here. So we'll try to draw that as accurately as we can. Even though there aren't any points here, try to line your ruler up so that it does go through the diagonals of each box. I mean, if we can do that, and if we know that's the pattern, then let's use that. Try to graph it as accurately as you can. If you're off just a little bit with your 3, maybe you graphed like this, 1, 2, 3. If you're off just a touch, over here you're going to be off even more, so that's a little bit sloppy. This gives us a better point, but notice how we're still going to go through this one as well. So we can line up right here on the vertex and try to graph as accurately as we can right through there. Got it. And by the way, this portion right here, this line would have a negative slope, and it's a -1, down 1, right 1, down 1, right 1, and so on. And this half would have a slope of +1, up 1, right 1, up 1, right 1.